and subject to risks and uncertainties. Please refer to today's press release at intc.com for more information on the risk factors that could cause actual results to differ materially.
Good afternoon, and thank you for joining us today. It's great to be with you again. Back in March, shortly after I rejoined Intel, I unveiled the evolution of Intel's Integrated Device Manufacturer, or IDM model, IDM 2.0. This is our winning strategy to remain a leading developer of process technology, a major manufacturer of semiconductors, and the leading provider of silicon globally, during what I believe will be a sustained period of global demand. There are three key aspects of IDM 2.0. First, we will continue to build the majority of our products in our internal fabs using our internal factory network. Second, we will expand our use of third-party foundry capacity across our portfolio to deliver the best products in every category in which we participate. Third, we will invest to become a world-class foundry business and a major provider of U.S. and European-based capacity to serve customers globally. Since we last spoke, we have been moving at a torrid pace to deliver on this strategy. I am proud of the progress we are making, but there is still so much more to do. In addition to the more than $20 billion in investments we announced previously for our Arizona site, we shared additional investments, including the $3.5 billion in our New Mexico facility to support manufacturing of our advanced packaging technology. And there is more yet to come. While a primary focus of our last webcast centered on the strategic decisions and investments we've made to build more manufacturing capacity, today I want to zoom in on our process and packaging technologies. Delivering leadership products requires the right combination of process and packaging, silicon and platforms, software, and at-scale manufacturing. This is a combination only Intel has, including our unquestioned leadership and breakthroughs in areas like 3D packaging technology. But, as you've heard me say before, we need to accelerate our clock rate of innovation. Today, I will share with you one of the most detailed roadmaps we have ever provided spanning process and packaging technologies. A roadmap that shows how we will continue our unquestioned packaging leadership and how we will get to process performance parity and then leadership sooner than you think. Before we dive into the technology and what customers can expect from us in the future, I'd like to first tackle one of the more confusing issues faced by our entire industry, node naming. Intel, like the rest of the industry, has recognized that we need to evolve the way we talk about process nodes. For those not as familiar with how we build chips and what we mean by nodes, let me give you a simple explanation of a few critical pieces relevant to today's discussion. Microprocessors consist of billions of transistors connected together in a specific pattern. These transistors are on-off switches that process the ones and zeros of electrical data. A region at the top of the transistor is called the gate, and this determines whether the transistor is on or off. The process node refers to the intricate recipe for thousands of steps we take to build these transistors. The goal is to make them smaller, faster, cheaper, and more energy efficient, all of which leads to more powerful chips. Originally, process nodes were named after the physical length of these transistor gates and were measured in microns. As transistors became smaller and the gate length shrank, we started measuring in nanometers. In 1997, as the technology continued to progress, other innovations such as strained silicon, aside from just shrinking the transistors, became equally important to making them faster, cheaper, and more energy efficient. This is when the traditional naming approach stopped matching the actual transistor gate. The industry diverged even further in 2011 following our introduction of FinFET, which was an entirely new way of building transistors with unique shapes and structures. These days, the various naming and numbering schemes used across the industry, including ours, no longer refer to any specific measurement and don't tell the full story of how to achieve the best balance of power, efficiency, and performance. So today, we're refreshing our lexicon to create a clear, consistent, and meaningful framework to help our customers have a more accurate view of process nodes across the industry to make better informed decisions. Let me walk you through it. We are already in high volume production with the 10 nanometer superfin node that we introduced last year, with the largest single intranode enhancement in Intel's history. This name will not change. Based on performance and power projections, our next node, which we previously called Enhanced Superfin, now becomes Intel 7. Intel 7 will be followed by Intel 4 and Intel 3. After Intel 3, the next node will be called Intel 20A. This last change reflects that Moore's Law is alive and well. As we get closer to the 1 node, we will be moving to naming that better evokes a new era, where we are crafting devices and materials at the atomic level, the angstrom era of semiconductors. We have a clear path for the next decade of innovation to go to 1 and well beyond. I like to say that until the periodic table is exhausted, Moore's Law isn't over, and we will be relentless in our path to innovate with the magic of silicon. Our new names are based on key technical parameters that matter to our customers: performance, power, and area. We'll go through all this in more detail today. A few of the technologies we have talked about before, and others you'll be seeing for the first time. To help unpack the incredible innovations Intel is delivering today and developing for tomorrow, I'd like to welcome the leader of our Global Technology Development Team, Dr. Ann Kelleher. Ann?
Thanks, Pat. It's a pleasure to join you today. Process and packaging are at the very heart of Intel's heritage and the foundation of everything we build. Today, we will unveil our process and packaging roadmaps that show how we're accelerating to deliver an annual cadence of process and packaging innovations through 2025 and beyond. With the exploding demand for silicon across a swath of applications, it's also important to emphasize that many of the innovations we discussed today will also be available to our Intel Foundry Services customers. We have many innovative technologies to cover, and I'm really excited for you to see what we've been up to. First, let's begin with what we have in production today. We have made tremendous progress with our Intel 10 nanometer process technology. Again, remember that the new naming structure will begin with the node after 10 nanometer superfin. We have ramped our production into high volume in 3 factories. That's in Oregon, Arizona, and Israel. Furthermore, our volume production has crossed over. This means we're manufacturing more Intel 10 nanometer wafers than 14 nanometer wafers. In short, 10 nanometer is doing really well. Now let's look ahead at what's coming, starting with our next process generation. We have previously referred to this node as Enhanced Superfin. Now let's look ahead at what's coming, starting with our next process generation. We have previously referred to this node as Enhanced Superfin. We're expecting Superfin as we evolve the node with additional transistor level optimizations. This is equivalent to a full node of performance gain. As a result, we believe that Intel 7 is an appropriate name to help customers understand the kind of competitive performance being delivered by the node. Intel 7 realizes this big jump in performance thanks to amazing innovations including moving electrons through the channel faster by using increased strain and more low-resistant materials, delivering better energy control through novel high-density patterning techniques and streamlined structures, enabling improved power delivery and better routing and higher metal stack. We will begin shipping products on Intel 7 later this year. The Alder Lake Klein family will start rolling out in 2021, followed by Sapphire Rapids for the data center, which will be in production in the first quarter of 2022. Intel 4 comes after Intel 7 and will be ready for production in the second half of 2022 for product shipping in 2023. These products include Meteor Lake for client and Granite Rapids for the data center. In March, we told you we had put the previous issues with this process node behind us. I think it's important that we spell out what that means. First, we hit an important milestone when we taped in the Meteor Lake client compute tile last quarter. Beyond the actual wafer, we're right where we expect to be relative to our performance and defect density expectations. Indeed, our defect density trend is on the right path to meet our product commitments. Intel 4 is also our first node to fully embrace the use of extreme EUV lithography, or EUV. EUV involves a highly complex optical system of lenses and mirrors that focuses a 13.5 nanometer wavelength of light to print incredibly small features on silicon. This is a vast improvement over prior technology that used light at a wavelength of 193 nanometer. Intel and ASML have a long working relationship, and we are confident that working together we will be able to support our requirements. As EUV evolves, Intel plans to adopt the latest tools as soon as they become available. This ensures our fabs have the latest features from ASML to deliver the highest productivity in support of our technology requirements. Ramping EUV into volume requires an entire ecosystem surrounding the equipment: photoresist, mass generation, pellicle production, and metrology, and we have put a great deal of effort into building this ecosystem. In fact, Intel's IMS subsidiary is the primary supplier of EUV multi-beam mask writers worldwide. These tools are essential for creating high-resolution masks, which are a critical part of enabling EUV lithography. This mask writing technology is a competitive advantage for us, as well as a key enabler for the industry. We are working together also to define, build, and deploy the next generation of EUV tools, referred to as high numerical aperture EUV, or High-NA. High-NA will integrate even higher precision lenses and mirrors, improving resolution and allowing for even smaller features to be printed on the silicon. We expect to receive the first production High-NA EUV tool in the industry and intend to be the first to implement High-NA in production beginning in 2025. Progress also depends on close collaboration with other key industry players. Our partnerships with equipment vendors, including Applied Materials, Lam Research, and TEL, are critical to enable our roadmap of leadership technologies. I am so proud of the work we have done on EUV lithography and other equipment technologies over the last several years. Intel 4 will be followed by Intel 3, which will be ready to begin manufacturing products in the second half of 2023. Intel 3 will continue to reap the benefits of FinFET. In fact, our early modeling and test chip data is showing that Intel 3 will deliver around an 18% transistor performance per watt increase over Intel 4, along with additional improvements in power and area. These amazing results derive from several factors, including the addition of a denser, higher performance library beyond Intel 4, increased intrinsic drive current to fully optimize the FinFET transistor, an optimized interconnect metal stack with reduced via resistance, and increased use of EUV compared to Intel 4. This is a higher level of improvement than a standard full node improvement for us. Our next node after Intel 3, as Pat said, will be called Intel 20A, marking the start of the Angstrom era of semiconductors. Intel has a long history of foundational process innovations. We led the transition from strained silicon at 19 nanometer to high-K metal gate at 45 nanometer. We led again with the introduction of FinFET at 22 nanometer. All these innovations propelled the industry forward by leaps and bounds as we continued the relentless pursuit of Moore's Law. Intel 20A will be another watershed moment in process technology when we introduce it in the first half of 2024. It will feature two groundbreaking technologies: an entirely new transistor architecture named RibbonFET, a first-of-its-kind innovation called PowerVia to improve power delivery. Here to tell you more about both of these amazing technologies is Dr. Sanjay Natarajan. Sanjay leads the team developing our future process technologies. Sanjay.
Thanks, Anne. I am pumped to take the wraps off two innovations that I believe will transform silicon process technology as we continue to push the boundaries of physics. The first is our new backside power delivery network called PowerVia. This is a unique technology developed by Intel engineers and will make its debut in Intel 20A. Traditional interconnect technology connects on top of the transistor layer. With the resulting intermixing of power and signal wires, routing inefficiencies arise, hampering both performance and power. Our solution is a novel process where the power wires are placed underneath the transistor layer on the back side of the wafer. By eliminating the need for power routing on the front side of the wafer, more resources become available to optimize signal routing and reduce delay. This also enables better power delivery by reducing droop and lowering noise. This allows us to optimize for performance, power, and area, depending on the product needs. We have been perfecting this process over the last several years, and PowerVia will be an industry-first deployment of a backside power delivery network. As we look to productize this innovation, our defect density, performance, and reliability give us confidence that it will be ready to ramp into production. In fact, we expect to test PowerVia on earlier nodes to ensure this groundbreaking technology is fully ready before it ramps in volume with Intel 20A in 2024. These test chip and SEM images show the structure of our PowerVia here. We can't wait to get PowerVia into customer products so that they can reap the benefits. And there are even more innovations to come. Intel 20A will also introduce our first new transistor architecture since we pioneered FinFETs in 2011, gate-all-around transistors. Gate-all-around has been in development across the industry for several years, and the name comes from the transistor architecture. Wrapping the gate completely around the channel means better control and a higher drive current at all voltages. This delivers faster transistor switching speeds, which ultimately translate to higher performance products. And by stacking multiple channels, called nanoribbons, we can achieve the same drive current as multiple fins, but in a smaller footprint. Our implementation of nanoribbons enables the width of the ribbons to be modulated to accommodate multiple applications. We call our version RibbonFET. These test chip and SEM images show the architecture of our RibbonFET. Based on test chip measurements, we expect our RibbonFET transistors to deliver performance and density improvement beyond today's FinFET transistors. The introduction of Intel 20A with PowerVia and RibbonFET highlight Intel's innovation leadership. Beyond Intel 20A, Intel 18A is already in development for early 2025, with refinements to RibbonFET that will deliver another major jump in transistor performance, along with clear process performance leadership. But you're going to have to wait a little longer to hear more about that. Because predictability is critically important to our customers, we have put a concerted focus on schedule predictability throughout our development process. This frees Intel's innovation engine to lead in high differentiation areas, such as PowerVia and RibbonFET. I am truly proud of the team and can't wait for our customers to realize the incredible benefits of products built using these technologies. Back to you, Anne.
Thanks, Sanjay. And thank you to you and your team of engineers for their hard work on delivering these innovations. Our engineers in the fabs in Oregon, Ireland, Israel and Arizona are working to get the sites ready for Intel 4, Intel 3, and Intel 20A production. Another area in which Intel is driving industry-leading technologies is advanced packaging. Packaging is becoming even more important as we now need to scale and stack tiles vertically to realize the effects of Moore's Law. Packaging is also a crucial component for our IDM 2.0 strategy, enabling us to create leadership products incorporating disparate nodes and processes. Let's start with EMIB, Intel's 2.5D solution. Now, Intel has been shipping EMIB since 2017, but here's a quick video refresher on the technology. Not only will Sapphire Rapids be the first Xeon product to ship in volume with EMIB, but EMIB enables Intel to build products that were impossible a couple of years ago. Indeed, Sapphire Rapids really is a big deal. It is the first dual reticle size device, delivering nearly the same performance as monolithic designs in the industry. That's a great achievement, but we have to build it in a cost-effective manner. Here again, EMIB is a great solution. Sapphire Rapids' structural cost will benefit from EMIB's inherent efficiency of using local silicon interconnect embedded in the substrate versus using a large silicon interposer. By comparison to a standard package interconnect, EMIB has twice the bandwidth density and 4 times better power efficiency. With current EMIB technology already in production, we are working on the next generation of EMIB, starting with solutions for future high-bandwidth products. Our next generation EMIB will scale from the existing 55 micron bump pitch to 45 microns and will then move to 40 microns in the third generations. We are also using that 45 micron pitch EMIB on a 92 by 92 millimeter package, which will be the world's largest ball grid array package. As we look at Foveros, Meteor Lake is our second generation implementation of this advanced packaging technology in a client product. Meteor Lake with Foveros will feature a microbump interconnect pitch of 36 microns, tiles spanning multiple process technology nodes on the same product, a dynamic thermal design power range from 5 to 125 watts. We can't wait to get Meteor Lake into the lab for testing in anticipation of volume manufacturing. And as we said in March, our Ponte Vecchio GPU will be the first product powered by both EMIB and second generation Foveros. In addition to assembly technologies that enable interconnect scaling, we have industry-leading advanced sort technologies that allow higher precision identification of known good tiles prior to EMIB and Foveros-based packaging. These innovations help us optimize product performance and yield, which are keys to affordable manufacturing. Intel's foundational advanced manufacturing technology, EMIB and Foveros, along with our assembly and test technologies, enable us to deliver leadership products to our customers that redefine integration. As Pat pointed out, many of these innovations and technologies will be available for both Intel products and our foundry customers' products. But we're not resting on our laurels and are working on innovations beyond EMIB and Foveros. If you look at the roadmap we presented at Architecture Day last year, we briefly talked about 2 new technologies. omnidirectional interconnect, which we're calling Foveris Omni, and hybrid bonding interconnect, or Foveris Direct. I'd now like to welcome Dr. Babak Sabi to join us and share more about Foveris Omni and Foveris Direct. Babak leads the team driving our roadmap of future packaging innovations. Babak.
Thank you, Anne. Let's start with Foveris Omni, which we expect to be ready for volume manufacturing in 2023. Foveris Omni provides unbounded flexibility for modular design and die-to-die interconnect as part of our ongoing shift to wafer-level packaging. As the name Omni implies, Foveris Omni allows integration of multiple disaggregated top tiles with multiple base tiles. Both the top die tiles and base tiles can be mixed across fab nodes. With this flexibility, the design possibilities and performance improvements are literally endless. This sounds like magic, but here it is in reality. Foveris Omni uses a combination of through silicon via and through package copper columns to balance high-speed signal and power delivery with dense die-to-die interconnect. It improves on the original Foveris with die-to-die interconnect starting at 36 micron and scaling down to 25 micron micro bump pitch, which quadruples bump density to 1600 IOs per millimeter square, all while delivering the same interconnect power of Foveris at 0.15 picojoule per bit. Now let's look at hybrid bonding, which will also be ready for volume manufacturing in 2023. We call it Foveris Direct. The name Foveris Direct stems from the move to solderless direct copper-to-copper bonding, which enables lower resistance interconnects. This technology will transform heterogeneous integration and truly takes packaging technology to the next level. We are blurring the lines between where the wafer ends and where the packaging begins. Foveris Direct enables sub-10 micron bump pitches. This provides an order of magnitude increase in the interconnect density for 3D stacking. The resulting capability of 10,000 IOs per millimeter square opens up new concepts for functional die partitioning that were previously unachievable. For example, one could have a multi-level cache or logic stacking on a die with very low latency without any power penalty. I can't wait to get these two new packaging breakthroughs into customer hands in 2023. Our unique advantage is the ability to combine any of these leading advanced packaging capabilities to create truly amazing products. With that, I'll send it back to Anne.
Thank you, Sanjay and Babak. This is absolutely amazing stuff. At the end of the day, all these technical innovations mean our customers can count on Intel to continue delivering products with improved performance and lower power consumption. These products will fuel the continued digitization of everything and create world-changing technology that improves the lives of every person on Earth. But of course there is more. I want to take a moment and preview what we're thinking about beyond 2025. On the process innovation front, there's more to gate-all-around and backside power, and this is already in the works. For example, we're already working on future nodes beyond 2025 that utilize stacked NMOS and PMOS and take gate-all-around to the next level. To continue our leadership in advanced packaging, we're looking beyond the delivery of Foveris Omni and Foveris Direct in 2023. As we continue to push the envelope in advanced packaging, we will be transitioning from electrical to optical packaging with integrated silicon photonics in future generations of our technology. And of course, we continue to work closely with partners in the industry, including Leti, IMEC and IBM, on these and many other innovations to further our process and packaging technologies. With that, I'll hand it back to Pat to close out today's webcast.
Thank you, Anne, Sanjay, and Babak. Wow, truly awesome. I hope you've enjoyed seeing a bit more detail on what we're doing and hearing from some of the smartest technologists leading our innovation engine. Collectively, these innovations will continue our leadership in packaging and will put us on a clear path to process performance parity in 2024 and leadership in 2025 with the introduction of RibbonFET and PowerVia. It's also important to remember that all what you've seen today is being developed here in the U.S. In fact, the process technologies we've discussed today will begin high-volume manufacturing in our Oregon fabs. If you think about it, we are the only leading-edge player doing both R&D and manufacturing in the U.S., creating a domestic lab-to-fab pipeline. But even more needs to be done to ensure a geographically balanced supply chain for the world. This is why we're aggressively adding capacity across our fab network. As you've heard me say before, we expect to announce the sites for our next expansions in Europe and the US before the end of this year. These will be large investments, enough to support mega fabs, and it's how we will help the world get to a more balanced and sustainable and secure supply chain. While we are already moving forward with some of these investments on our own, we applaud the policymakers in both the US and EU for acting with urgency on programs that will accelerate our progress and the progress of others in the industry. We are encouraged by the recently announced CHIPS Act to support semiconductor manufacturing and R&D in the US, and we're excited by similar efforts underway in the EU. In summary, Intel is innovating the future of process and packaging technology. Intel will deliver those innovations on a regular cadence, will enable a wider cross-section of the industry to take advantage of our amazing technology. Like I said earlier, we are moving at a torrid pace, and the industry is responding eagerly to the fact Intel is back. So let me close by emphasizing the progress we are seeing with our own foundry business. One of the strengths of IFS is that we offer both leading-edge process and packaging innovations, as well as modernized access to our historical technologies. The interest from customers in IFS has been strong, and some of the most intense energy has been in our proven advanced packaging technologies. I'm thrilled to announce we have signed AWS as our first customer to use IFS packaging solutions. But there's more. I'm also excited about the opportunity to partner with Qualcomm using our Intel 20A process technology. Both Intel and Qualcomm believe strongly in the advanced development of mobile compute platforms and ushering in a new era in semiconductors. IFS is off to the races. We have dramatically accelerated our innovation pipeline, and wow, that was quite a lot of process and packaging ground to cover. And you can hear even more about Intel's incredible innovation machine at our Intel Innovation event on October 27th and 28th. Join us in San Francisco or virtual. This event will be fully hybrid. Thanks for your attention. With that, let's go through some live Q&A. I'm excited to be here in the studio today with Anne, Sanjay, and Babak, and we'll be happy to take questions. So, operator, how about a reminder of how folks can ask questions and then send us the first one? Operator, how about a reminder of how folks can ask questions and then give us the first one?
Voice is on mute.
Operator, if you could give us our first question, please.
Again, ladies and gentlemen, to ask a question, you will need to press star 1 on your
Interesante.
telephone keypad.
Así que muchas
To withdraw
gracias y nos
your
vemos por
question,
la
press the
página web.
pound
Así
key.
que
And as
cerramos
a
el evento en
reminder, we would
directo
like you to
y
limit your
hasta
questions to
otra.
one.
No sé si escucho nada de la
And our
falta,
first
pero
question is from Anand Tech.